good morning to all. This is chapter name is super semiconducting materials. Okay, so what do you mean by semiconducting material? That means it neither be a insulator nor be a conductor. That means it lies between both conductor and insulator. That is called as a semiconducting material. Okay, so these are the contents of your topic, like introduction and simplify of silicon and germanium atom, interatomic bond intrinsic semiconductor, extrinsic semiconductor, difference between silicon germanium semiconductor, difference between p-type, n-type, and working and application of semiconductors. Okay, so today we'll discuss about only the introduction regarding the semiconductor. So introduction. A semiconductor material whose conductivity lies between that of conductor and insulator, that is called as a semiconductor. The most commonly used semiconductor materials are germanium and silicon. Okay, these are the two popular semiconductors. Okay, that is germanium and silicon. And the atom, we know that atom is one of the smallest particle which contain proton, electron, and neutron. So come to the point, what is semiconductor? The semiconductor are those material which lies between conductor and insulator, that is called as a semiconductor. Okay, so and the most commonly used semiconductors are silicon and germanium. Conductor, so what is conductor? It is those substance which, so come to the point of conductor. It is those substance in which electric current pass through easily. Example, your silver, iron, copper, gold, aluminum, human body, earth, salt. These are the examples of the conductor by which electric current can pass through easily. That is called as a conductor. And all the conductors materials, conducting materials are the PTC. What is the PTC? Means positive temperature coefficient. That is, temperature is directly proportional with resistance. Okay, so if the temperature increases, then resistance is also increases. If resistance increases, then temperature also increases. That is called as T directly proportional to your R. That is, temperature is directly proportional to your resistance. So in terms of energy band, okay, in terms of energy band, the valency and conduction band overlap with each other in case of conductor. Due to this overlapping, the potential difference, the slight potential difference across the conductor causes a free electron to constitute the electric current. Okay, so here two bonds are overlap with each other. Okay, and the forbidden energy gap in case of conductor is your like 0 electron volt. And the semiconductor, what is semiconductor? It is those substance which lies between conductor and insulator. Example, silicon and germanium. Forbidden energy gap. What is the gap of the what is forbidden energy gap? Forbidden energy gap means it is a gap between the conduction band and valency band. There is a gap. I will show you. There is a gap between two bands. That is called as a forbidden energy gap. Okay. In case of conductor, it is 0 electron volt. But in case of semiconductor, the forbidden energy gap is 1 electron volt. So semiconductors are NTC. NTC means negative temperature coefficient. Negative temperature coefficient means T inversely proportional to your 1 by R. If temperature increases, then resistance decreases. Okay. If resistance increases, then temperature decreases. Okay. So this is known as a NTC. Like in conductor, PTC, positive temperature coefficient. Like in case of semiconductor, it is NTC. So in terms of energy band, the valency band is almost filled. Okay, in the energy band, the valency band is almost filled and the conduction band is almost empty. So now see the energy band diagram of all. First we will discuss about the insulator. Okay, so we already discussed semiconductor. Now come to insulator. What is insulator? Insulator are the substance in which electric current cannot pass through easily. That means here you can't here electric current cannot pass through easily. Example, glass, wood, dry, air, okay, sulfur, wax, oil. These are the different types of insulator. We can say that gas, like something gases also insulator, like SF6 gas. We have a SF6 gas, that is also insulator. Okay, air, we can say air is insulator, or we can say there are different types of examples. Okay, that is called the insulator. So what is the forbidden energy gap in case of insulator? It is always greater than 8 electron volt. Okay, it is always 8 electron volt forbidden energy gap. But that case of conductor, it is 0 electron volt. In case of semiconductor, it is small energy gap, that is 1 electron volt. But in case of insulator, it is greater than 8 electron volt, maybe 15 electron volt, maybe 14 electron volt. Okay, so insulators are ZTC. What is ZTC? Zero temperature coefficient, because here temperature is 0. But in case of conductor, your temperature is directly proportional to your resistance T, directly proportional to R. In case of conductor, in case of your semiconductor, T inversely proportional to your resistance. But in case of insulator, you have a zero temperature coefficient, that is T is equal to 0. Okay, so in terms of energy band, in terms of energy band, the valency band is full, while the conduction band is empty. See that diagram. This is the overlapping diagram. Overlapping diagram means it is a conductor. Okay, there is a small energy gap, that is 1 electron volt. That is this is your what? This is your semiconductor. Okay, large energy gap. Okay, that is here. It is a insulator. Okay, clear all of you guys? So next, yeah, simplified of silicon and germanium atom. Okay, we know that octet rule. Okay, so before know about the atom, we know the octet rule. Octet rule, that means it obey. Octet rule means 2, 8. Okay, 2, 8, and like we know that octet rule. I will tell that. Okay, the electrical characteristics semiconductor of those conductor and insulator. A semiconductor means has a 4 electron in the valency ring. That means your silicon, the atom number is your 14. Okay, so outermost means you know about that 2, 8, 4. You can know the rule 2, 8, 18 like that. You know the rule of octet rule. Okay, so there is one theory is there. Okay, 2, 8. Okay, so in 14 we can outermost orbit, we have a 4 electrons in the valence ring. Okay, so the two most widely used semiconductors are silicon. Silicon means it is a 284, and another one is that is germanium, that is 28184. Okay, that is 32. So we can 32. So we can 2, 8, 18 and 4. So outermost must be 4. Okay, that's why we can say that these are the semiconductor. Okay, so silicon and germanium is the most popular semiconductor. Okay, so yeah. So next, characteristics. What are the characteristics? Those of conductor. Overall 95%. Okay, overall 95% of solar cell. We know the solar cell about that. Solar cell which converts sun into electricity. Okay, 95% of solar cell produced worldwide are composed of semiconducting material, that is silicon. Okay, these are the one of the best application of silicon. Okay, as second most element earth crust, silicon has a advantages and also available in sufficient quantities. Okay, so outermost must be 4. Okay, like we have a rule that is KLMN. Okay, outermost, that is a theory that KLMN. So 2, 8, 18, another rest. Okay, so that is silicon and germanium. Okay, so according to silicon it is 2, 8, 4. So now come to bond.